whatever we learn in the RNN part. So I'm introducing these sequence to sequence model because of we going to be learn so many things in upcoming classes with by using these concepts. So you can see in the encoder part we have some chunks here, or you can say some subparts. So these are all cell states. You can say cell states. Whether it is a LSTM cell or whether it's RNN cell, that does not matter with us. So it is a cell state. We are going to be represent for each and every chunks. And in the decoder part also we have different chunks. But you can observe directly here in the encoder part and also the decoder part, we don't have any kind of output results in the encoder. It cannot be produced any kind of the output results. You can see in the decoder part it's going to be produce some output results with corresponding to each and every cell. So what will happen in the encoder part and what not to happen in the decoder part, and in middle also what will happen, how does it going to be represented as some different context. So you can see here, if suppose in the NLP context you just have some sentence, we already represented and we already understand these sentences in the RNN part also. So if you go and see how does this going to be splitted together as a words and also converted into the vectors, we are going to be passed into these contexts or these kind of the cells to represent it as an input to this. So if you input to this some of the words or some of the vectors to take this consideration, and it's going to be learn something, and it may not be give some output, it may not be produce any output according to this. What it will do, it will produce whatever the information I have in the cell 1, it's going to be give to the cell 2, that's it. Similarly the cell 3 and cell 4. So what will happen, it will reach eventually the cell n, it will hold some of the, you can also call the end of the string. End of the EO is nothing but end of the string. So it will eventually learn this is the end of the string. We need to pass this input or the historical data, you can say this is the historical data. So this historical data I need to pass to the decoder model or decoder vector representation to the first layer of the decoder. So what will happen in this case, whatever the information you have taken from the all the encoder cells, what we had, we're just passing to the first layer of first cell of the decoder model and try to understand this much of the information from the encoder, and it will going to be preserved, or it going to be preserved. We can also call it as the begin of the string for the encoder, for the decoder of the first cell. So what will eventually get all the information, and it's also take some input according to whatever we have showcased, and we're going to be produced as a output results. Similarly, it will also pass this information to the next cell. It's also give some information with respect to the input value what we had. It's also passed to the next information, produce the output. So let's take some example called, you had you want to be converted from English sentences to Hindi. Let's take. So what will happen eventually? You have a two checkboxes. If you Google it out, you have a two checkboxes to translate any kind of the words. So what will happen? You type something, some words here, English words, and also it will going to be get as a Hindi words. So according to what, how many words you are going to be represent, and how many words you are getting. So that's how you can analyze some way, so that it is little bit easier when compared to the to understand the encoder and decoder model. So you can see we are just passing some of the information, but what will happen, you will get in terms of the milliseconds, if you understood or not. If you get in terms of the millisecond, that's how they implemented that much of low latency requirement. So if you implemented this from scratch, it may takes maybe 5 minutes of the time to get the results. Maybe you are not sure about that. So if you try to do from scratch, it maybe takes 5 minutes of the time, it maybe eventually takes 1 hour of the time to do that. But what will happen eventually, we are going to be retrieve any kind of the implementations or any kind of the APIs whoever have deployed or whoever have implemented that by using some of the good raw data sets, and also you can say some tons of the notebooks and also the Wikipedia pages. So we are going to be take that kind of the pre-trained mechanisms and try to apply on top of our data sets. So this is called as something called transfer learning. in the deep learning mechanisms. So we are just learning because of transferring whatever they have implemented to implement in our data sets. That's it. So we're going to be seeing a lot of the things in the transfer learning and in terms of the CNN mechanisms, so that you will get some idea how to use that and where to change, where not to change some of the things. So let's also focus more on something called as we discussed backpropagation algorithm yesterday. I hope you remember. So if you understood the backpropagation algorithm, this is very easy to implement. So we just said whenever you implement any kind of the nodes in terms of the backpropagation algorithm, we just shown as weight initialization. So we have so many different initializations of the weight. Let's go and check out on this page. So I'm page of the Kaggle. Kaggle is a very beautiful resource, I can say. I will also preferable to learn so many things from the Kaggle. If you are not aware of the Kaggle, this is very preferable for the data science and the machine learning concepts. You can also log in and if you go to this Kaggle website, you can see competitions, data sets, code, discussion. So many things are there. Even you can learn so many from different persons. So I'm also the page of some person. So he written very brilliantly how to initialize the neural networks. So we have different initializations. I will discuss with the different initializations. Then we can also go with some difference between the each of them. So I have one initialization called. I also discussed yesterday something called as zero initialization or random initialization, zero initialization. I'm just passing zeros of the weight initializations what we had in the back propagation algorithm. So I represented this yesterday. I will also showcase what are the disadvantages with respect to this, and also random initialization and something called as he initialization and something called as Zoriot initialization. Zoriot initialization. So let's go and check out these kind of the different initializations and also the differences between both of them. Yeah, you can see. And yeah, if you take this consideration for the zero initialization, what will happen if you're just passing all the nodes with corresponding to the weights as a zero. So w1 is equal to 0, w2 is equal to 0. So it is only for the forward propagation, you can say. It is only for the forward propagation. It's not a backward propagation, because what will happen if you eventually going to be update some of the weights with respect to the loss function you had, the derivative of the loss function with respect to the weights, it may not be helpful at the time. Only for the forward you're going to be initialize something. So if you apply these zero kind of the initialization, this is how the plot going to be looks like. So you already know, probably you may learn in the 11th and 12th grade, at the point of zero, you may not be differentiate dl by d0, you can say. It may not be differentiate, and at that point you cannot be try to understand how to go forward or how to do come of the computing the weights at the time. So zero initialization may not be helpful at that time, and also represented by using this graph you can see here. So we already learned so many classification techniques like SVM also we have learned, and what are the different disadvantages we had along with the logistic regression and random forest models. So if you take this diagram and showcase into the classification model, if suppose I have these kind of the data points to represent it as a classification task. Let's take this is the red points as one class, and this violet is another class. So I have these two different classes. So I need to classify these things. That means I need to represent or to separate these two different points by using the hyperplane. How does I going to be doing? If suppose I drawn like this, no, I will not separated. If suppose I drawn like this, it may not be separated. If suppose I draw middle, maybe middle, not like this, right? So similarly, whenever you initialize any kind of the zero initialization, it may not be separated according to the whatever the pattern you're going to be showcase above the diagram. So this is a somewhat looks like the logistic curve also. If you observed while we using for the sigmoid function, right? So this is also called sigmoid function and sigmoid curve. So if this is the case, we cannot separate anything. We have to be very conquer about these kind of the points and try to apply the SVM maybe to get some good kernel, and RBF kernel may be helpful at that point. So if you take another kind of the random initialization with some of the mates, instead of taking only the zero initialization, random means we are going to be get any number maybe. So if suppose I ran this cell, suppose you have this cell, right? So I ran this cell in p dot random. So at the time I may get around 2, maybe randomly I'm taking some value. So wi is equal